Hi students, 12th standard chemistry unit 5 coordination chemistry. So in this session I am going to teach you metal carbonyls. Okay, first what is metal carbonyl, that you should know. Okay, when carbon monoxide group is attached with a metal, okay, here this is called carbonyl group. Let me draw the structure here for carbonyl group. So it is having the lone pair of electrons. Those lone pair of electrons will be donated to the transition metal. Okay. So it is called metal carbonyl. Metal group is attached with a carbonyl group, or otherwise carbonyl group is attached with any of the transition metal. Okay. So this is called metal carbonyls. Okay. Here we have given one metal carbonyl, nickel tetracarbonyl. It is homoleptic carbonyl. Homoleptic in the sense the ligands will be are of same kind. Okay. Heteroleptic in the sense the ligands will be different. Okay. See here four number of carbonyl group is present. So the ligands are all same. It is attached with a transition metal which is nothing but the nickel. Okay. So this was first discovered in 1890 by Mon. Okay. So these metal carbonyls are of industrial importance because they are readily to release the carbonyl group from them. Okay. So let us see the classification of metal carbonyls. Okay. Metal carbonyls can be classified into two different types. The first one is, it is classified based on the number of metal atom present. The first classification is based on the number of metal atom present in it. Okay. It can be of two types. The first one is mononuclear and the second one is polynuclear. Okay. So the first type is, let us discuss now, mononuclear carbonyl. Mononuclear in the sense it will have only one kind of ligand, it will have only one kind of metal atom, means that is called mononuclear carbonyl. If it is having more than one, metal atom, means that is called heteronuclear or polynuclear carbonyls. Okay. We will see the example now. Here they have given nickel tetracarbonyl. This is having only one metal which is nothing but the nickel. Nickel is attached with the 4 carbonyl group. So it is nickel tetracarbonyl and the shape of the molecule will be tetrahedral. Okay, it will have the simple structures only. And the next one is iron pentacarbonyl. In this case also only one kind of metal atom is present, that is nothing but the iron. Okay. So the shape of this molecule is trigonal bipyramidal, and the next one is chromium hexocarbonyl. Okay. So here the metal atom present here which is nothing but the chromium atom, and it will be attached with the 6 carbonyl group. So it is called octahedral shape. It will have the octahedral shape. Okay. So these are all the mononuclear carbonyls and these are all the structures that what they will possess. Okay. So the next one is polynuclear carbonyl. Polynuclear carbonyl in the sense they will have more than one kind of metal atom. They will have more than one metal atom. So that is called polynuclear carbonyls. They are also divided into two types. One is homonuclear, heteronuclear. Homo in the sense same kind of metal atom will be present here. Hetero means different kind of metal atom will be present here. We will see what is homonuclear now. Okay. Dicopal octa carbonyl. Dicopal octa carbonyl. Here 2 cobalt group is present. Okay. 2 metal atom is present. So if I write the structure, I will write like this. I will write the remaining carbonyl group. So in this case will possess the same metal atom. It is of 2. Okay. Then the next one is dimanganese decacarbonyl. Dimanganese decacarbonyl. Here also they will have the same metal atom, but they are having 2 metal atom in this. Okay. So it will comes under polynuclear carbonyl. Then the next one is heteronuclear carbonyl. Heteronuclear carbonyl in the sense the metal atoms will be of different kind. See here I am having manganese as well as cobalt. See here, I am having manganese as well as rhenium. So, if the metal atoms are different means that will comes under heteronuclear carbonyl compounds, that too will comes under polynuclear carbonyls. Okay. So, this is the first classification. This is nothing but the based on the number of metal atom present in it. So, the next classification is based on the structure. Okay. The second classification is based on the structure of the carbonyls. Okay. So, here we are having two types. One is non-bridged metal carbonyls and the another one is bridged metal carbonyls. Non-bridged metal carbonyls in the sense, here in this case, listen carefully, the ligands, which is nothing but that the carbonyl group will be attached to the only one kind of ligand. The carbonyl group will be attached to the only one kind of ligand. So, it is called non-bridged metal carbonyl. Let me write the structure here. So, nickel is at the center, carbonyl. All the carbonyl groups donates a pair of electrons towards the nickel atom. All the carbonyl groups donates its electron to form a bond. Okay. So, it is nickel tetracarbonyl and the next one is iron pentacarbonyl. Okay. See here, what did I tell you? What is non-bridged metal carbonyl in the sense? So, in this case, the ligands will be attached to the ligand in the sense the carbonyl group will be attached to the central metal atom. Only one kind of central metal atom. There is no any kind of bridging over here. Then the next one is chromium hexocarbonyl. So, chromium at the center. All the carbonyl groups I am writing. So, this is chromium hexocarbonyls. Okay. And this is also called terminal carbonyls because these carbonyls are attached to the only one kind of ligand. Then the next one is another case in non-bridged metal carbonyls, it will have the terminal carbonyls as well as the metal bond. Okay, the example is they have given dimanganese decacarbonyl. Let me draw the structure here. There should be a metal bond between these two, manganese, dimanganese, in the sense I have written the manganese group here, then the remaining cobalt group I have, the carbonyl group I have to write. So, all the carbonyl groups donate its electron to form a compound. So, these are all the carbonyl groups. Here also bridging is not taking place. So, it is a terminal. So, these are all the terminal carbonyl groups. Okay. Then the next one is we have seen non-bridged metal carbonyls. Then we have to see the bridged metal carbonyls. We will see now. So, the next type is bridged metal carbonyls. Bridged metal carbonyls in the sense there is a presence of two or more bridging carbonyls will be there. Okay. So, let us see the example now. So, the first example is Fe2CO9 diiron carbonyl. Let me draw the structure here. So, I am having two metals it will be attached with a 5 carbonyl group. So these are all the called terminal carbonyl groups. And it will have 3 bridging carbonyl group. So in this case, how many terminal carbonyl groups are there? 1, 2, 3, 4, 5, 6. So 6 terminal carbonyl groups are present. How many bridging carbonyl groups are present? 1, 2, 3. 3 bridging carbonyl groups are present. Then the next example, Dicopal octa carbonyl. This structure will have 2 isomers. Okay, let me see. Let me draw the isomers first. We are having 2 metal atoms. So in the first case, there is no bridging. All the carbonyl group is directly attached to the metal atom. This is the first possibility. Why I am writing the arrow mark? Because all the carbonyl group donates its electron towards the central metal atom. So this is the first case, and the next case is, I am writing the metal atom. It is having 6 terminal carbonyl group and the remaining 2 bridging carbonyl. So in this way we can write the structure of the carbonyls. It is having 6 terminal carbonyl groups and it is having 2 bridging carbonyl groups. Okay, hope it is clear. Thank you.